In this video, we will explore two fundamental concepts that define a ship's stability behavior. Those are statical stability and dynamical stability. Statical stability, or transverse statical stability, refers to a ship's ability to return to an upright position after being heeled or tilted by external forces such as wind or waves. This form of stability focuses on the ship's initial response to heeling, and is primarily concerned with the relationship between the center of gravity and the center of buoyancy. A key parameter in assessing transverse statical stability is the metacentric height, gm, which is the distance between the center of gravity, g, and the metacenter, m. A positive gm indicates that the ship will generate a righting lever or righting arm, gz, so a righting moment will form that will tend the vessel to return to its upright position when heeled. Righting moment at any angle of heel is the moment that represents the ability of the ship to return to its initial position when heeled by external forces. Righting moment is equal to righting lever times the ship's displacement, and it is expressed in tons meters. Righting lever, gz, is the horizontal distance between the lines of action of buoyancy and gravity forces when the ship is heeled. A larger gz indicates a greater righting moment, and it corresponds to a stronger tendency for the ship to right itself. There are several formulas for determining the righting lever. In these formulas, theta represents the angle of heel. When a vessel is heeled at 10 degrees or less, it is considered a small angle of heel, and you can use this formula. At a large angle of heel, a wall-sided formula must be used. This formula can be used at small and large angles of heel. Before we proceed to a graphical representation of the righting lever, the GZ curve, and calculating the moment of statical stability, or righting moment, let's define first dynamical stability. Dynamical stability defined as the work done in inclining the ship, or the energy required to heel a ship to a specific angle. It is quantified by the area under the righting arm known as the GZ curve up to that angle of heel. This area represents the energy needed to incline the vessel and provides insight into the ship's ability to resist capsizing under dynamic conditions. A larger area under the GZ curve indicates greater dynamical stability, meaning the ship can absorb more energy from external forces without capsizing. This is the formula to determine dynamical stability. Looking at the formula to find moment of statical stability and dynamical stability are interconnected concepts that together provide a comprehensive understanding of a ship's stability behavior. The righting moment, a key aspect of statical stability, is calculated by multiplying the righting arm by the ship's displacement. Dynamical stability, on the other hand, is determined by multiplying the ship's displacement by the area under the GZ curve. Let's proceed with a calculation using this GZ curve that I have made in my previous video. If you want to see the full details how to construct this GZ curve that you can see on your screen, kindly visit the link in the description below. At a 10-degree angle of heel, the GZ value is 0.12 meter. So the ship created a righting lever of 0.12 meter, and this is the point in the graphical representation. To determine the moment of statical stability, or righting moment, multiply the righting lever at 10 degrees angle of heel, which is 0.12 meter by the ship's displacement. To determine the dynamical stability, multiply the ship's displacement by the area under the GZ curve. This is the area under the GZ curve at a 10-degree angle of heel. We can determine this area using the Simpson's rule, but we will do some calculations when we are up to 30 and 40 degrees angle of heel. Observe the ship's righting lever as she heels at 20 degrees. The righting lever increases to 0.30 meter, and the curve forms up to 20 degrees angle of heel. The area under the curve also increases. So at 20 degrees heel, the moment of statical stability and dynamical stability also increases. Now looking back at the ship's righting lever, as she heeled to 30 degrees, the righting lever still increased to 0.54 meter, so as with the area under the GZ curve also increased. Both moment of statical stability and the dynamical stability also increase. Let's do some calculations. The ship's displacement at her loaded condition is 27,970 metric tons. At 30 degrees angle of heel, the ship's righting lever is 0.54 meter. If we multiply it by the ship's displacement, the moment of statical stability is 15,103.3 tons meter. To determine the dynamical stability at a 30-degree angle of heel, multiply the ship's displacement by the area under the GZ curve of up to 30 degrees. The dynamical stability is 3,300.46 meter-tons. In my previous video, I showed you how to calculate this area under the GZ curve at an angle of heel of 30 degrees using Simpson's second rule. If you want to see the full details, kindly check the link in the description below. Now going back to our scenario, at approximately 38 degrees angle of heel, the ship's righting lever reaches its maximum, and the area under the curve also increases. As the ship continues to heel at a 40-degree angle of heel, her righting lever starts to decrease, but the area under the GZ curve continues to increase. If you want to calculate the dynamical stability, the area under the GZ curve up to 40 degrees angle of heel is 0.229 meter radians, using Simpson's first rule. Now, as the ship continues to heel at a 60-degree angle of heel, the righting lever continues to decrease, but the area under the GZ curve continues to increase. As the ship continues to heel at an angle of 67.5 degrees, she gets zero righting lever, and the area under the GZ curve still increases. Remember that if the righting lever decreases, the moment of statical stability also decreases. And if the area under the GZ curve increases, the dynamical stability also increases. But even if there is a decrease in the moment of statical stability, an increase in the dynamical stability means that more work should be done to incline the vessel, or it requires more energy for external forces to incline the vessel. So a larger area under the GZ curve indicates greater dynamical stability, meaning the ship can absorb more energy from external forces without capsizing. That's all for now. I hope you found this video helpful. See you in my next video. Thank you for watching. Bye.